Thank you for the introduction. I didn't expect such a detailed introduction. My focus is basically at Cisco to create proof of concepts, as Martin mentioned, and then transition them into products if they are successful. My specific area of interest is everything that happens between the device and the database. So we talked about sensors this morning, and what happens when you produce bits and you have to take those bits all the way to an application that will consume those bits. So this is my area of focus. So the first slide is my attention grabber slide. So to grab your attention with a fun fact. So this is a slide that comes out of a study from our company. We made a study about the data flow in data centers, where the data comes from, how it goes in and out, and who consumes it, and who produces it, and so on. And a fun fact is that if you take a city of 1 million people, in 2020, this city will produce 200 million gigabytes of data per day. That's a fairly significant number. And the reason why I put up this slide is because there are some different areas where the data is coming from. You can see it. Data is produced by the transport sector with the connected planes. It's produced by the factories. It's produced by the hospitals, and so on and so forth. So you have multiple verticals which all contribute to the generation of this data. Now, McKinsey published a study last year, and they said that if you take the whole overall value of IoT and if you quantify this, 40% of the potential value of an IoT solution comes from interoperability. So this is a fairly large number. So disparate systems talking to each other and exchanging information to create something that you didn't know before. And they estimate that the potential economic of IoT as a whole is $11.1 trillion. So 40% of that is about interoperability between systems. That's a large number. I guess I have your attention. So why is interoperability a problem? So how do we get to this problem that we are facing now, where nothing can talk to anything else? If you have a typical IoT solution is made of multiple things that you put together, and they have to talk to each other in one way or another to create an outcome. The printer, for example, what drives me crazy is when I go to my print room and I have to stand by the printer for 30 seconds. It's not long, 30 seconds, but I stand by because the printer is asleep, and I just wait until the printer comes up. It would be nice if the light bulb could tell the printer, hey, Lionel is coming, so warm up. So I don't have to wait. But the thing is, when the people build printers or smart light bulbs, they didn't expect that those two had to talk to each other. So they didn't design the product in that way. So that's problem number one. From the manufacturing time, things are not designed to talk to each other readily. The second issue is the people who make the actual IoT solutions. If you, amongst you, are coders and you say, I will code this solution, I will make this work, then you make it work for a Xerox printer and a Philips light bulb. But what happens when now you move to another building and you have a different brand of Xerox printer and you don't have the same light bulbs? You have to start all over again. Now, let's take a look at the closed systems. You could say, well, IoT solutions now, they are self-contained. There is no problem. I mean, you can build a solution to address any problem. You build the protocols, the APIs, you have your proprietary system, and everything works well. And you can buy this and consume it, and it sells. So what is the problem? Well, let me show you an example of a closed system. So this is the video surveillance cameras that are installed on policemen. So a couple of years ago, the federal government decided to fund 50,000 cameras for policemen. and it's about $400 a piece. And the idea is to archive the video for a certain amount of time. So the largest deployment is in Oakland. So in Oakland, California, just across the bay from where I live, they have 600 cameras deployed. Actually, they had this last year. So the market is in full expansion. It's a successful business. This is great. Everybody makes money here. This is nice. So the solution works like this. You have the camera and the police officer at night when they come back from their shift. What they do, they take the camera and they put it on a cradle. The camera offloads its data onto a computer, which pushes this onto a video management platform, which, by the way, is managed and owned by the same vendor that sold the camera. So they have an end-to-end solution here. They can sell it as is. However, not all cameras are created equal. So, for example, a camera keeps filming all the time, and when the police officer pushes a button, usually what it does, it takes a 5-minute buffer and adds it into the video. So when you push the button, it's not the beginning of the video that is saved. It's actually 5 minutes into the video, or 3 minutes or whatever. So some cameras are constantly buffering the images, but some take the sound and some don't have sound. Some cameras have a monitor on them and some don't. Well, if you have a monitor on a camera, then you can, the policeman can see what he's filming. Also, maybe the video may be available to the officer before they file the report, so the officer can look at the video and refresh his memory of what happened, and then file a report. But you can imagine that this could be also, it could present another situation. There should be a blinking light or not on the camera while it works, or maybe you can have a screen that is facing outward, so you can see that you're being filmed as you talk to a policeman. Now, as you can imagine, that all those things have a profound effect on how the system will be used eventually. And it's very possible that the Oakland Police Department wants to change models, right? Maybe there is a competitor that has a better camera with some of those features that they want to have. So what happens to the Oakland City when they want to do that, when they want to introduce another vendor? Well, this is what happens. So they bring in another vendor which has another software and another backend, and eventually they end up with two systems. So you see where I'm going here. So how about if we did something like this, where we had a middleware, and this middleware would aggregate the data from the various cameras, and on the back side, we have the video management systems which could consume the videos produced by the cameras. So what we've done here, we have separated the producer of information on the left and the consumer and the application on the right. So how is that done usually? Well, most likely you will have a system like this. I just put OpenDaylight here. This is a platform we've been working on. It's an open source platform that can do this middleware business here of aggregating this data. So what happens is, in a typical solution, you would have devices, and they would be fitted with some sort of client binding software. On the client side, you have to format the data in a certain way and send it somewhere. So you have your client application running on the device, and there is a plugin infrastructure in the middleware, on the middleware side, and the plugin infrastructure's job is basically to decapsulate the traffic it receives and store it in the database. This database, this local database, is basically a staging ground for the data, and the database is not a data lake. It's just there for maybe a few minutes, or maybe a millisecond, or maybe a day or two, until it's consumed by an application northbound. Today, most of the cloud IoT providers will give you a solution like this, and they will have the middle layer embedded into their solution. So Google and Amazon, they will sell you IoT solutions, and basically the middle part is theirs. So if you have a device that you want to connect to one of these clouds, you take their SDK, you install their SDK on your device, and then off you go. You're ready to connect. Now the issue is, okay, if I pick Amazon's SDK, can I send my data to Google? Well, probably not. And this is where we enter the standards mess, if you will. So 30 years ago, I remember when I started working in this field, we had the choice between Ethernet and Token Ring and FDDI. We had the choice between IP, DECnet, and AppleTalk. So those choices were at the bottom here of this stack. And things have been pretty much stable. So you can imagine that your thing will output some IP traffic, will connect to the network with a known technology at the bottom, which has been vetted. So if it's a cellular device, then you have a 3GPP connectivity, and you have a modem compliance to a spec, so you don't have to worry too much about this. So your choice of access data may be difficult, but that in the end you'll end up over IP at some point. So you're over IP, and then what? Well, you see the layer at the top is much more crowded than the layer just below. So now the question is, over IP, what do you use? Do you use HTTP? Oh, maybe it's too large of a header. It's too power consuming for your device. Your device cannot afford it because your device battery will be consumed for every bit you transmit. So you want to have the shortest and most compact protocols. So maybe you'll go with something like co-op, which is the moral equivalent to HTTP for the machines. Maybe you'll go with MQTT. But then you remember this middleware layer that we had in between. The middleware layer has to receive what the device sends. So there needs to be some agreement between the two parties so they can actually get to talk to each other. So you have stable standards at the application layer. I mean, HTTP, for Christ's sake, is stable, right? But you need to make sure that the other guy is actually picked the same standard. And what's worse is if you go one layer above. So you have received now the payload, but what does it mean? If I send you a blob of bits, you need to have some sort of roadmap to understand what exactly the sensor is saying. What is it? Am I talking to a plane or to a computer or to a door? So there is a data schema that has to be defined and agreed upon, so eventually the applications can consume the data that you output. Now this is fairly difficult to achieve. Convergence will take time. I don't believe that it's going to happen anytime soon, personally. But there needs to be some pressure from users. So the people who buy those IoT solutions, they absolutely need to ask themselves, what will be my way forward as I deploy my solution inside my building once I embed my sensors in my walls, and in a few years I want to change? Am I going to get stuck with one vendor that sold me that solution, that IoT solution? So absolutely the users must ask that question to the people who sell them and deliver them IoT solutions. In my opinion, there also needs to be pressure from the top. From the top, I mean the government. I know regulation is not really a popular topic these days in the US, but I believe that this is a place where the government can play an interesting role. For example, in Europe, they were thinking about delivering a label of conformance to appliances, smart appliances going into homes. So if there is guidance from the top, then it's not a problem for a device manufacturer to implement a protocol as long as they know which one to implement. It usually takes, if it doesn't need any hardware modifications, it usually takes a few folks and a few weeks or maybe a few months to comply to a spec, as long as you know which one you have to comply to. And lastly, creative solutions. Maybe you from the academia, you can come up with creative ways to address this issue, but I will leave you with that. If you create an IoT solution and you have your device in front of you and it's a great device and you know you will get a lot of value out of it and you want to connect it to the rest of the world, it's very tempting to just implement the minimum API for your solution to work. But just pause at this point and think about how your device will be consumed by an entity that has nothing to do with you. How difficult will it be for that entity to get to your device and tap into your data? Just think about it and design your product so it's easy for a third party to do that. Thank you.
We have time for one or two questions. Any questions?
So when you talk about consumable interfaces, where the data stream, for HTTP, XML created a self-defining screen where the metadata described the product. When you start to talk about some of these other interfaces, is Cisco doing anything in terms of creating kind of self-defining objects that if I'm using a sensor to communicate, is there any standards that you know that are coming out there? Or is this something that you're looking for from the smart home industry to actually create?
That's a good question. So we don't own devices. In the IoT thing, we're the I, but we are not the T. And we work with very closely with some partners, some chip vendors. And one standard that comes to mind to me is a BLE. So BLE, they had the genius strike they decided to implement the data schema on top of their transmission model. And so if you connect to a BLE device, you can know if the device is a heartbeat monitor. So I'm very hopeful that this will eventually take off, and I'd like to take this BLE ecosystem into the realm of full IoT solutions and not just mobile devices connected as a gateway, but more in terms of mainstream IoT solutions with fixed infrastructure.
I have a question with the example you showed earlier, the policeman video data system. Sounds like that's an integrated system. The company provided the camera and acquire the data and then analysis of the data. But in terms of, you also mentioned that there may be different camera system that can or cannot be used. So in terms of this question, it sounds like Apple integrated system versus Microsoft, right? And so when people do use other cameras, how that data system going to play into this? Do you have comments on how this is going to be, played together?
So what I suspect is when they use other cameras, the discussion of interoperability will come up, because either the federal government may say, for example, the minimum requirements for your cameras moving forward will be X, and in that case, that will force the manufacturers to go into one direction. So again, pressure from the top is needed. Or the second portion of that is, of course, if a police department wants to reassess their posture, they will immediately see that the systems are incompatible. And they will have to ask maybe the other vendor to provide an API to their existing system. But even that is not a good solution, in my opinion, because you're still stuck with the first system that you bought. Although solution is to have, in my view, one solution is to have this middleware common ground where you can pour data in, and so everybody can consume it. That's where I hope that the industry would go eventually. So if I have to pour my data into Amazon Cloud or Google Cloud, I shouldn't have to modify my data to do that.
Thank you very much, Lionel.
You're welcome.